to start with sharing your slides while I give a short introduction? I think we have 7 people in the call now, 11 have registered, so if there's someone late, then they can ask afterwards, and we can give a short introduction of what we've done. Yeah. Great. Hello.
See my slides now?
Yeah, I can. Can everyone else? If there's no no's, then we assume that everyone else can see the slides. Perfect. Hello, everyone, and welcome to the Reconcell open call webinar. Thanks for registering and being here today. So today we'll give short information on the open call, and you'll also be able to ask questions afterwards. Most of the information you can also find in the guide for applicants, but we have prepared the presentation to go through the most important information with you. So from Reconcell, we have in the call Alej Rude from the Institute. They are the coordinators, and the work cell is also at their institute. With Alej, we have the developers of the work cell from the institute, Robert, Timo, and Martin. And I'm Franziska Kirsten from Ocean Robotics. We are in charge in Reconcell of the commercialization and then also for the overall management of the open call. And now the agenda looks like following. Alej will give a short introduction to the project, the current status of the development, and what we are looking for in the open call. And then I'll continue with the call details and some other useful information on the proposal work. Just some organizational things. I think you've all muted your microphones. I think that's very good. So we only have always one person who's talking. That gives a better quality of the sound. And I would suggest that if there's no really urgent questions, we would keep the questions for later. But of course, if there's urgent questions, on understanding what is being presented, then I would you just ask right away, so we have that covered. Okay, then Alej, was there something else? Otherwise, I would suggest we just start.
Okay, then let's start with my presentation. So the idea of this presentation is that I first give you a few slides about the Reconcell project in general, and then we are going to focus on issues, on technical issues that are relevant for this call. And then afterwards, Franziska will explain the whole procedure, how the application should be submitted, and what is part of the submission. So let me start now first with the short introduction of the Reconcell project. So the idea of the Reconcell project is that, what we want to address in the Reconcell project is that still a lot of production is done manually these days in industry. And robots are primarily used for large batch size production, but especially small companies, but also bigger companies also have more customized production or few-of-a-kind production. But the problem here is that the setup time for automated robot solution is still too long, and which makes such solution expensive, and that's why there's no business case for them. So the main problems here is that you need a lot of engineering knowledge to program new tasks in Reconcell. You require some programming skills. Sensing is often an issue, and the result of this is that there is a lot of trial and error before things start working, and that's why especially smaller companies often avoid using robots because it's simply not practical for them. So the consequence is that then the production process is done manually, and then the cheapest way is often to outsource it outside of Europe. And then, but if you lose production, then slowly knowledge about the production processes is also lost. So that's not good also for companies. So how we want to address this in Reconcell is that we propose to, or we developed a new kind of robotic cell that supports actually programming of fast reconfiguration of the work cell to new products so that you can quickly switch between products and basically the production of small batch size production becomes profitable in such a work cell. So the main technologies that we used here are new reconfiguration technologies and new programming technology, which allows us to quickly program assembly tasks and thereby reduce reliance on experts. So if I quickly go through the main technologies that are included in Reconcell. So first of all, so on the right side you can see the video, so I hope you can see it, but in any case I'm going to explain it if it's not visible well enough through the web interface. So basically we provide facilities to first design the work cell in a way that is suitable for the production. So basically there is a frame that allows you to set up the work cell in such a way, structure of the work cell in such a way that is suitable for your production quickly. We provide a kinesthetic teaching interface which allows you to quickly program new tasks in the work cell. Then we provide also the learning and adaptation capabilities to actually adapt the tasks if necessary to new products. There is some facilities for sensing, and so basically you can use 2D and 3D vision in the work cell. There is a simulation system that supports both the design of the work cell and programming of the work cell, and there is some support for checking, if the proposed production is actually profitable for the work cell for the company. So basically, how this cell was designed, there are 5 key partners that especially collaborated on the technical design of the work cell, and these partners will actually also help or actually implement the production task that come from that is accepted in this open call. So these key partners are Joseph Stefan Institute. Here the whole work cell is located and your experiments will be conducted here. And then there are 4 other partners. So one is University of Aachen, MMI, who are doing the simulation. Then we have SDU from Odense and University of Göttingen from Germany, who are basically concerned with vision and gripper design. And the last partner is Hermia, who is responsible for business modeling. And you are, of course, not the first people who are going to test this cell. So there are already 3 SMEs who are collaborating in the projects. And I'm going to explain a little bit now about the experiments which have already been done in this work cell, and basically this should be a good guideline for you to help you when you propose your own experiment. And then, of course, not least is the Blue Ocean Robotics, who is actually responsible for, in the context of this call, Blue Ocean Robotics is actually responsible to run the whole evaluation process and monitor that everything is going well during the actual during the time when we actively work on the experiments. So the first example that I want to mention is the assembly of automotive lights. So what you can see on the left side of these slides are 2 different lights that needs to be assembled in the work cell. So of course, if you want to assemble such lights, you need to basically prepare a workplace so that you can fix the lights, so that the lights are stable in the work cell and that the robots can work on them. But if this is to be done, then you need to have some reconfiguration ability in the work cell. And this reconfiguration ability is provided through these hexapods. These are flexible fixtures that can be moved by the robot itself. and you can basically prepare the work cell so that this lights can be placed into the work cell without actually changing anything in the work cell except for the configuration of these hexapods, which can be done by the robot itself, so it does not need to be done manually. So how the process then looked like is that we first find in simulation the appropriate configuration of the work cell. We figure out what kind of grippers we need for the actual assembly task. Thus, these grippers can be then 3D printed, so to make it suitable for the actual objects that needs to be handled in the work cell. And then finally, on the right side, you can see how the assembly, one snapshot from the actually assembly process. So this is actually seen in this video. So Francisca, can you tell me, can this video be seen?
Yes, I can see it.
Yeah, okay, excellent. Yeah. So you can see here that basically here this workspace has already been prepared for this light. So basically the robot places the light first onto the work cell that is prepared for the light, and then it starts assembling the objects that need to be inserted into the light. So here constantly we are changing the grippers. So here you can see some magnetic grippers that allows you to change to grasp some of the objects in our work cell. And you can see here on this slide here now the robot actually is changing the gripper. So here so basically it used the gripper, and then it grasps the camera, which is used for quality control. Here you can see again some more of the gripper exchange, and you can see now here how the quality control process runs in the work cell. So of course this is all highly configurable and needs to be designed for different products. So now basically the product has been assembled successfully. It has also been quality checked, and now the robot basically tries to now the robot will reconfigure the workspace so that the next light can be assembled. So this will be done now. So you can see, no, this is not now. Sorry. So now we actually started to. So now the robot is actually first needs to change some pins that are needed to actually place a different light onto the fixtures, and then after it will change the pins. So let's skip some of this. You can see here that the robots will now start changing the fixtures. So this is now happening here. And now he will put new pins into the fixtures, and these pins are then used to place the next light. So let's skip a bit again, and you will see now that the robot will now he's not yet finished with the. No, he now actually grasps the next gripper, and he will now grasp the next light housing, and this light housing will be then put into the new fixture, into the prepared place. So you can see basically that everything that has changed in the work cell is basically the positions of these fixtures. And now basically this light is now the second assembly process is started again with a lot of gripper exchange and some quality checks to ensure that the light is properly assembled. And here on the right side up, you can see basically the whole process also in simulation. So basically the simulation, the whole process is first check in simulation and then implemented in the real work cell. So I want to stress now what is the reconfigurable hardware here in the work cell. So we have here these reconfigurable fixtures that can be used to prepare the workplace. So this basically allows you to change how to position the objects, different products in the same cell. Then you have this frame which can be put into different configurations, and it can be prepared so that your product can be assembled. Then we have these trolleys that can be easily added to the work cell. So this is to supply the parts into the work cell. And here we have this so-called plug and produce connectors, which also allows us to change to know about the position of the trolley with respect to the work cell. So basically, once you plug the trolley into the work cell, no additional calibration is needed. Then the fourth way to change the configuration of the work cell is also to actually move the robots along this linear axis. So if you have a product that needs to be, where for assembly we need to place the robots at different parts of the work cell, this can also be done. And the robot can actually, so you can actually see in this video that the robot moves itself along this axis. And this is done by actually grabbing some parts of the object, the cell, a handle in the cell, so just like you would grab the handle when you want to move along some fence or something like this. So besides these four technologies that are visible here, there is also a tool exchange system that allows you to exchange the grippers, and we also support the design of grippers so that you can design appropriate gripper and 3D print it for your task. So this is not the only use case that we implemented. So this use case was implemented from the automotive industry, but it is not meant that you need to, now in your experiments use all these configuration capabilities of the work cell. So if it's useful for you, you should use only this reconfiguration that is necessary for the implementation of the use case. And so in this case of Precisica Metal, it is not necessary of the use case of Precisica Metal, which is the assembly of a robotic gripper. It is not necessary to actually use these flexible fixtures, so we are not using them in this experiment, but we make a lot of use of tool exchange system and 3D printing, and of course work cell design technologies to configure the cell so that it is suitable to assemble different parts of the gripper in the same workplace. And the third example is the example from the company Logic Data, which is the final assembly and customization of dry system and control boxes. So these objects are actually part of furniture, some smart furniture, which has some electronic parts in it, and basically we are assembling these electronic parts in this work cell. And again, these parts are different, as the order of the company changes. These parts are depending on the furniture, you need different parts, and we need to support these different parts in the same work cell. So again, here we use a lot of kinesthetic teaching, 3D printing. Of course, the design of the work cell layout is important, and so this allows us to quickly reconfigure the work cell to different dry boxes. So if you use facilities like the flexible fixtures and this linear unit that allows you to reconfigure the work cell, to reposition the robots to different parts of the work cell, then the reconfiguration is fully automatic. Other reconfiguration techniques, of course, require some user interface to reconfigure the work cell. So if I go now to Reconcell, to the setup that will be used in the experiments, so it's basically the work cell consists of 2 UR10 robots. So you don't need to use both if your experiment does not require it, so you can use 1 or 2. There is this reconfigurable steel frame that allows us to quickly design the place in a proper way. There are plug and produce trolley, passive reconfigurable fixtures, linear units for relocating a robot, 2D and 3D camera. The footprint is 4 by 3 meters. And the weight of the cell is about 1 ton. And you have, of course, power and the pressured air, which allows you then to drive different elements of the work cell. So when you decide for the experiment that you suggest in your application, so you need to actually consider that the payload of the robot is, for example, 8 kilos. So if you have a heavier object, this would not be suitable, of course. You also need to then consider what is the repeatability of the robot, what is the reach of the robot, and what kind of sensing is available in the work cell. So basically, besides the standard robot sensor, there is also a force-torque sensor if you need it. There is a tool exchange system, and there are cameras. So there are also some computers in the work cell that are used for programming. One is so-called master computer, which runs the whole work cell. And then there are 2 optional computers. So simulation you almost surely need, so it's maybe not that optional, but at least the vision computer, so it depends on you whether you want to use vision in your experiment or not. And there is, of course, this tool exchange system that is also very important because virtually every assembly task we encountered until now requires you to design different grippers that are suitable for accurate assembly of different parts. So then we have a few words about the software. So we are using ROS to run the complete work cell. So you have then the ability to connect all these different devices into a central system. To program the task, you can use programming by demonstration. So this is relatively quick. So we are essentially demonstrating how the robot should move, and we use the system also to calibrate different elements of the work cell. So we basically guide the robot. If you place a new element into the work cell, you guide the robot toward this element and then simply record the position of the element in the work cell. So there is also a simulation software available which allows you for visualization and then also for initial work cell layout and programming. And then there is some graphical user interface for task programming, and there is a vision software available that you can use. So basically, how will now this implementation look like? So we expect in the open code that you define an experiment that is relevant for an SME. So basically, the consortium can contain, in consortium there can be different, of course, also the research organizations, but we are especially looking for use cases from SMEs, so, and the research organization can, of course, then support the SME in defining their experiment and then in the implementation phase. And then, so that the actual implementation will then look like so that once so the experiment will be already defined in your proposal, but then when we actually implement this, this will be primarily done at Joseph Stefan Institute. The time is short, so you will not be required to actually, program the complete work cell by yourself. This will be done, the actual programming of the cell will be done by the people at my institute, so Martin, Robert, and Timo, and some other people, and of course also by the other partners of the Reconcell project. But it will be required that some of you are present, and help during this programming phase, because you know best the technological requirements of the experiment, and you should also then help to, with the programming so that we really program what is required for your use case. So what does the company that suggests the experiments actually get from this? So you can basically, check if if some assembly process that is currently done manually, if it's actually feasible to do it in a workcell like Reconcell. So how would the ideal experiment look like? So we are always looking in Reconcell for some experiments where you would have several variants of the same product. So basically, it is difficult. It is more difficult to reconfigure the workcell if these are of course completely different products. But normally, if there are some variations in the product that needs to be assembled, this can be solved with our reconfiguration and programming technologies. So we do not deal with the soft object in our cell, so we would prefer to have rigid objects. And you should try to make use of components in the current setup of Reconcell. So essentially, if new hardware is necessary, this needs to be budgeted in your budget. So normally, what would be necessary is, for example, some specialized gripper or something like this, and then materials for 3D printing, which is not totally cheap either. So such stuff you should put into the budget. So probably the budget is not big enough to buy, full robots. And in any case, we would not want to, put additional robots into the work. So, but some smaller parts that are necessary for the implementation of the experiments can be part of your budget. So the assembly sequence should also be not too long, so because then this requires too much programming and testing for the short time that we have to implement these experiments. So basically, we said that we would like to limit this to 5 parts. So I think this is not such a hard limit, but you should try to keep it reasonable. Yeah, and you should also not replicate something that already exists or something that has already been implemented. So we want to do something new that shows that some new capability, some new product has been assembled where the assembly was done manually before, or with some special machines. So because it is also advantageous, of course, if you can assemble the product with a general purpose robots as opposed to the specially designed machine, which is normally not practical for small series. So this will be all from the technical side of the Reconcell project and these experiments. There will be question time after we finish the presentation. But I would now first give the word to Franziska to actually explain the how to actually submit your proposals.
Exactly, yes. And you can already go to the next slide. So this will be more about the proposal work. We start with the call details. So the call opened end of November, and it will be open until March 1st, 5 p.m. Brussels time. The indicative budget for funding is €85,000. I'll go into detail in one of the next slides there. The duration for one experiment is around 3 to 6 months. And you need to submit your proposals electronically. That is only possible on the proposal submission platform. You can see the link here, and it's also in the guide for applicants, where you can see the link to the portal. So some important documents for you is the open call text, where you can find the information on the call details, then the guide for applicants, where also the information that Alish has just presented and the information that I'm going through now are described in a bit more detail, and then the proposal template that you need to fill in your actual proposal text. Yeah, next slide.
Just a second.
Yes, about the proposal itself, the proposal language is English, the proposal format is PDF, and the main part of the proposal should not be more than 7 pages. You can see the structure here. There's 5 points under the structure with an indicative length per section. There's the first one is the summary with just a half a page. Then most focus is on the assembly task description, where you can also put in some pictures. You will also be able to upload a video together with the PDF. So in case you would like to explain something in a little bit more detail, the video will be a good option for that. But here in this section, you'll also be able to put some pictures. It's 3.5 pages. Then a description on the industrial relevance and a preliminary business case that shows that Reconcell would be a good option for you. The limit here is 1 page. Then the budget and justification of costs and resources, that is also 1 page, and information about the participants with maximum 1 page. You don't need to have a management description because Reconcell will give you the management structure. And you can include an appendix about maximum 1 page with administrative data, a list of the participants, for example, the SME status, and the PIC code. If you don't know whether you have that or what that is, there's also a link in the guide for applicants. You can click on and find all the information for this. Okay, next slide. So the indicative budget per individual experiment, so per use case, is 85,000 euros, and it may not exceed that budget, and that should cover all third parties. So if you create a consortium with a university and an SME, that budget should still be 85,000 euros for both participants, so for the consortium. The third parties receive 70% funding, except if you are a non-profit organization, then it's 100% funding. That's the same for all Reconcell partners. So this is also going to be the same for the third parties. A very important statement in the guide for applicants for the applicants is that you should consider the actual need and not just target the 85,000 euros. So we will also evaluate this and the appropriateness of your requested resources in the evaluation process. And as Alish said earlier, all the additional hardware, software costs of components that need to be added to the Reconcell system should also be included in the budget. And also the implementation takes place in Ljubljana. And you also need to consider the traveling costs in your budget, because the winning teams might need to travel there to work together with JSI on the implementation, and also maybe a demonstration in the review meeting. Yes, next slide. So then the call eligibility and the budget. So all organizations that are also eligible to participate in H2020 projects can apply for this open call. Though, as Alish already mentioned, we are really looking for SME use cases. So that should be the focus of the proposal. The activities that are funded are personnel costs, other direct costs such as traveling, equipment, hardware, software, and other goods and services, and indirect costs, 25% of the direct costs. And the winning teams need to provide the information about the objects and the implementation of the use case. That is, for example, physical objects or the product in a sufficient quantity to support the use case implementation. So some of the partners in Reconcell, not only JSI, may need the physical objects. So there might be more than one needed for the implementation. Technical documentation, including the CAD models, information on how the product is currently assembled, and also some business case parameters. This will be done with Blue Ocean Robotics, analyzing the business case parameters and having some meetings on how you could profit from the Reconcell cell in your manufacturing setting, actually. Yes, next slide. So the evaluation, as you could probably hear from from Alish in my explanation that there's a huge focus on the actually quality of the use case specification so that it fits to the Reconcell and that it is something new that we can work further on to show the variability of the Reconcell work cell also. So here the fit to the specifications of the Reconcell system and the feasibility of the implementation are very important. The amount of Reconcell techniques associated with the proposed use case, Alish already explained that earlier, and also the existence of several product variants belonging to the same product family in the proposed use case. A good example here is the assembly of automotive lights, where we have a whole product family that can be assembled in the work cell. Then a second point is the innovation potential and impact of the proposal, including the relevance of the use case for manufacturing SMEs and the business strategy. And last but not least, the effective and justified deployment of resources. So also that you consider the actual budget that you need and not just the 85,000 that you can get from the open call. Yep, next slide. And I think we are at the question time. In case you have questions afterwards, you can also contact us via email. There's also my phone number in the guide for applicants. You can also call us in case there's anything you should think about afterwards that you didn't ask here. And we will also have a webinar on 7th of February again, where we'll probably present something similar again, because there will be some more new interested participants. But if you have suggestions on what else we could do there, then please also feel free to contact us and tell us that you need some more information on a specific topic. Good. Then I would say question time. Any one of you has some specific questions to the technical description or the proposal preparation itself?
Sorry, I have a quick question.
Yeah.
Just curiosity, we know that this is for experimentation, just to evaluate our one manufacturing process, the viability with this reconfiguration robot. But just as curiosity, what is the market? If there is any market proposition based on the Reconcell robot, the idea is that then in the future someone will be able to acquire this kind of robot, or the robot is only for training and validation of the process?
So in the Reconcell project, this is validation, but we are working on creating a company around the product so that you will be hopefully after the project be able to also buy the product in case you should be interested in that.
Because the question we had, of course, after we evaluate all the manufacturing process, we make all the configuration, all the validation with this robot, and we assume this robot, because all the benefits of this based on this open innovation, that is the reason we would like to know that at the end of the day you will not require to go to another totally different robot where all the lessons learned could not be totally transferred. So that is the reason, because one of our main worries is to make sure that in the future this robot that we will learn how to use in the experiment could be finally integrated in real industrial environment. And the hardest question, I assume you will not have an answer. You have any estimation cost for the robot, any rate?
I mean, the robots itself, single robots cost about 25,000 euros. So these are universal UR10 robots. So it depends, of course, what is the current price, and what's the tax in your country. But the whole work cell is, of course, here I don't have the final price, and it depends also on the configuration of the whole thing, But the whole software, two robots, and all these tool exchange systems and so on, this is targeted at about 100,000 euros.
Okay. Sounds quite competitive. We are quite surprised with the cost. It sounds very competitive.
Yeah, as I said, this is the target. Yes.
No, but means that will not be prohibitive, and if you are thinking about this spin-off company, that sounds really relevant because indeed it doesn't make sense to learn about that technology, to make a lot of effort during 6 months to understand how a product can be optimized, the manufacturing process, and afterwards you don't have the opportunity to really deploy in a cost-effective way the technology. So this makes much more relevant and interesting this kind of.
I mean, of course, we hope that you will that the company would then come to us to actually, so that we can, or this spin-off company to actually sell the Reconcell. But I think there's also, some other benefits for the company because you can basically, within this experiment, you can actually test if this is feasible, and this doesn't cost you anything actually. And so then, even if you would then decide to go somewhere else, you still have, the whole implementation telling you how to do it, and then maybe with some other system integrator you could then realize the same experiment.
Thank you so much, Alex. And last question, I'm sorry for taking too much time, but do you have already also some kind of commercial available robot from Siemens or other large companies that could cover the same functionalities like Reconcell, or at least could be a kind of replacement robot, or right now Reconcell is quite innovative and there is not a market available as alternative?
I think, if you look at the complete Reconcell, then it is quite unique. But of course, there are, single technologies that are available. So, we are using the standard tool exchange system within it, and the universal robots, of course, you can get from universal robots. And the cell, I also want to mention here that the cell is relatively, the cell is quite agnostic towards the robot. While this would be some cost to use different robots in this cell, it is definitely feasible and probably in the next step after establishing the company. So we will look at using also different robots within the Reconcell. But if you look now at the complete Reconcell as presenting here in this videos, this is probably unique at this point.
Excellent. So thank you so much indeed.
And also concerning the price, we're working on analyzing right now how the Reconcell can be sold, what the price is, what kind of service packages can go with it. So there might also be soon information if that's something that is also interesting for the applicants, then that we could also inform about.
Yeah, Francisca, that is really important because
that was a good comment.
We invest time. It's not only about, we know it's free to validate, but at the end of the day, we assume we will have a benefit, or the companies we are engaging will have a benefit, so they will want to put it in practice. And if it is not a clear, feasible plan to put it in practice, why we will show something that is good for them, and after we say, but right now it's not accessible, or this is extremely expensive, and because we are targeting SMEs so in the project. So that is the reason, because that kind of information is very crucial to have very clear from the beginning.
So that was a good comment. Very good. Great. More questions? That is very, very unusual, but then it seems the presentation has been quite clear.
Hello, can you hear me?
Hello?
Hello, yes, can you hear me?
Yes, yeah.
Oh, okay, thank you. Yes, I was wondering, you mentioned assembly. How would it be possible to think or to bring also an example of process integration? Or are you set on assembly only as a demonstration example?
So I don't really understand what you mean here with the process integration.
Well, basically, because what I mean is, if we were to, you have shown especially a system which is assembly assembling different things. But if
Yes.
we wanted to think about demonstrating the integration of your cell with, say, I don't know, a welding, for example, would that something that we could bring as an example?
So this is, it is a bit difficult for me to evaluate this without actually seeing the technical details. But basically, the cell has been done for the assembly, so probably assembly.
Some more details. I don't want particularly to say too much here, but I might, if I can contact you then with some more details. And
you can send to me and to Francisca more information, but I can. But maybe what I want to say is that this has been developed with assembly in mind. Now, of course, the robots are robots which can do other things, but most probably, if we go out of assembly, we will need more hardware to be built. So it really depends, how much additional stuff needs to be built into the Reconcell so that the task can be designed. So if I look at welding, welding of course has some difficulty with how you do the experimentation. So in the current environment, I think welding would be difficult. So I would not say I will not say that welding is impossible, of course, but the problem is that we need to basically then deal with all the safety issues that are involved with welding, and at this point it is difficult to say how much effort this is.
But if we were, for example, to think about doing the demonstration tower facilities, would that something that?
No, this would not be practical, because basically, to be actually able to implement this, you need to have a complete system or part of the system available at your facilities, and basically we are not yet selling the complete system to somebody, and we need to do this in a relatively short time. So this is definitely possible after the project, but now during the project we need to be fairly fast in implementation. So it also, if you wanted to implement this in your own site, then we would first need to do the whole training process so that you can run the cell by itself, and I think this would take too much time before we can actually, and this should be finished in 3 to 6 months.
All right, thank you very much.
Yeah.
More questions? Or comments also, whether you think this would be interesting or some more information that you would need?
I have a short question.
Yeah.
Maybe you said it before, but and I missed it, but who will evaluate the proposal?
The evaluation of the proposal. Hello. I don't think I heard everything. I don't know about the others, but I heard that your question: who will evaluate the proposals? So the evaluation will be done by selected people.
Hello.
Hello.
Can you hear me?
I can hear you. Can you hear me? Hello.
Hello, can you hear me? I can hear you well.
I can hear you. Can you hear me?
I'm asking Madeleine.
Yeah.
So the proposal will be
Perfect.
Evaluate the proposal.
Okay, Franziska, go ahead.
Okay, good. I hope you can hear me now. So the proposal will be evaluated by selected people from the Reconcell consortium, just because the consortium and those people are know the use cases, know the Reconcell work cell, and they will be the best to evaluate whether the use case is appropriate.
So there will be a committee, I believe, out of 5 people who will actually evaluate, of course, read all the proposal and grade it according to this criteria that are written in the guides for applicants, and basically the highest scored proposals will then be accepted. Yeah.
And the committee is with people from several backgrounds. So there's business, there's the developers, and also representative from one of the use cases that we have right now. Does that answer
Okay, thank you.
Yeah, good.
Yeah, thank you.
Great.
Hello, sorry, another question,
Yeah.
Franziska. We saw that right now for the current open call is only I think that a couple of proposals will be funded with the available budget. Is any future open call, or this is the unique one?
Again, the last part?
No, I mean, because with this open call, I think this will be the unique open call, or will it be other open calls in future?
No, this is the only one for Reconcell.
Yeah. Okay, and it is expected to fund 2 experiments?
Yes.
Yes.
Okay, perfect, thank you.
And how many proposals do you expect? Do you know some numbers?
Of course, we can't know this, but you can see that there are now about 11 people actually subscribed to this webinar. So probably not all will submit, and probably there will be some people who are not here who will submit at the end. But I don't know. I mean, it is everybody's guess, of course. I would. From this attendance now, I think maybe 60 proposals, but this is a wild guess, I'm afraid.
We also just started one more marketing campaign in the last week, so there might be coming some more SMEs, because SMEs are usually also not so aware of open calls, so we're trying to reach those as well, because they are our main target audience, and there might be coming some more in the next month. We'll probably see in the webinar in February also how many more there will be.
Hi, I was wondering if the presentation will be available somewhere.
Yes, we can actually upload that, and also the webinar is recorded, right, Alish?
Yeah, actually, I was not recording it.
I can see it's recording down here, and I think I4MS will put that on YouTube afterwards.
So actually, already now in the use in this meeting space, this presentation has been uploaded, so you can download it from the meeting space. And I mean, if it's Franziska, so maybe we can, put it somewhere after this call, and just send the link to the participants if somebody cannot download it from the meeting space.
Yeah, we can do that. We can put it on the submission platform also, where you can download the guide for applicants and proposal template and text. We can just put the presentation there, and then send you the link to the recordings of the webinar and also the presentation.
Okay, perfect. Thank you very much.
Yes. Is there any final questions?
Yes, one.
Great.
can you say how an ideal consortium should look like?
So maybe if I comment on this, so there is no. I can only give examples here because basically, somebody might propose some consortium that actually looks more reasonable than what I'm talking about now. So I can give you an example of what looks like a reasonable consortium to me. So considering how much funding there is, it is probably reasonable to have one SME in the consortium and maybe one research organization that supports this SME in carrying out the experiment. But this is, of course, not, prescribed by us. If somebody come up with a better idea, or maybe it makes sense, because one research organization doesn't carry enough expertise, then it is perfectly okay to have a different type of consortium.
Okay, perfect. And who should have the lead in the
or if the company has all the expertise in within the company, then this would be also an acceptable consortium. So the consortium of one is also fine. Yeah.
Okay. And should the SME have the lead, or can it also have the research partner? Is there any restrictions?
There are no restrictions. You need to decide by yourself what is best for your consortium.
Okay. Okay, thank you.
Great. We have 11 o'clock, so I think we can. If there's no more questions, maybe a final question. We can. Otherwise, that was exactly the timing we calculated, so fits to what we planned. Any more information that you would need from us? No, then I would guess I think we can finalize the webinar, and thank you everyone for participating. Just let us know if you have any more questions. You can write. There's the info at reconcell.eu email address. Feel free to contact us with any more questions that you have, or also participate in the next webinar again. Alice, do you have any?
No, I would just like to thank everyone for participating, and we are expecting your applications. Yeah, okay. So then let's
with some use cases.
Yes. Okay, so then I would say bye-bye. Yeah.
Thank you. Bye-bye.
Bye-bye.
Bye-bye. Thank you.